This is the second video of Module 2 on solving systems of equations. In particular, in this video, we're going to look at verifying whether or not a particular point is a solution to a system of linear equations. In order for a certain point, x, y, to be a solution to a system of linear equations, it must satisfy both equations. So in other words, it must make both equations true. In order to determine if an ordered pair is a solution to the system of equations, we perform a check. To perform this check, we substitute the values of x and y into both of the equations. You want to evaluate the left side separately from the right side, and then we want to form a conclusion. So if both the equations are true, then it means that it is in fact a solution. If one or both are not true, then it is not a solution. So we have a couple examples here. In example A, it says determine if the point 4, 1 is a solution of the following system. We can label our equations as equation 1 and equation 2. To determine if the point 4, 1 satisfies this system, we want to check whether or not it satisfies each of the equations. So our solution in question 4, 1, we would use the value of 4 for the x value and 1 as our y value, and we want to perform a check. So our check for equation 1. What we do is we plug in the values of x and y into the original equation. So the left side of the first equation is x minus 2y, and we're going to plug it in brackets, our points 4 and 1, and we see that it is equal to 2. The right-hand side of the equation is also equal to 2. Therefore, we say that left side is equal to the right side. We can now perform the same check, but with equation 2. When we examine the left side and right side separately of equation 2, we find that they both equal 5. Therefore, the left side also equals the right side. Since I should discuss graphically what this means is that the point 4, 1 lies on both of the lines, and since it lies on both of the lines, that's the point of intersection. Therefore, we say that it is a solution. In the next example, we want to check if the point 2, 1 is a solution of the following system. So again, examining each of the equations separately, we have equation 1 and equation 2. We can perform a check where we plug in 2 for x and 1 for y. So pause the video now and try the check for each of these equations. So after performing the check for the first equation, we see the left side equals the right side. That means the point 2, 1 actually does lie on the first line. Now when we perform the check for the second question, we can see what happens. Second equation, rather. Examining the left side, we find that it is equal to 5, whereas our right-hand side of the equation is equal to 9. Therefore, the left side does not equal the right side, and the point 2, 1 does not lie on that line. Therefore, it is not a solution. In order for it to be a solution, it must lie on both lines. What's wonderful about being able to perform a check is that anytime you're working on an assignment or a test and you have some extra time, you can actually check whether or not your solution that you determined is a solution to the system of equations by plugging it back into the original equations. It's worth spending the time to do that. You don't actually have to write it down like I have physically here. You can plug it in just in your head, or do a little calculation on your calculator and check whether or not it's a solution. I've plotted this example on Desmos, where we have our system of equations and the point in question as the point that we were wondering whether or not is a solution to the equation. When we take a look here, you can see that the system of equations, so the purple line and the black line, actually do have a solution. And the solution would be at -6, 5. But the point we were wondering about was 2, 1. 2, 1 lies on one of the lines, but not both. Therefore, it is not a solution to the system. It simply lies on one of the lines. In the next video, we'll be solving systems of equations using elimination, which is an algebraic method to solve for a solution.